This question is about applying Lenz's law and also your right hand grip rule to determine the direction of the induced current. So when you see questions that involve a coil and a moving magnet, when you apply Lenz's law on this kind of question, the steps is always the same. The answer to this question is A, and the steps will be as such. Always ask yourself these questions. What is the action? And let's say for option A, the action is that the magnet is moving away. Specifically, the south pole is moving away. So therefore, question number 2, when there is this action, what changes in the magnetic field does the coil experience? And therefore, for option A, the this side of the coil experiences a weakening south magnetic field because the south pole is moving away. Therefore, by Lenz's law, what induced pole will this side of the solenoid take so that we can oppose the change described above. So when the south pole is weakening, we don't want it to happen and we want to oppose it. Therefore, we should have an induced north pole here in an attempt to try to attract back the south pole that is moving away. And therefore, there you go, you have an induced north pole here and induced south pole on the other side. And the last step is to use your right hand grip rule to figure out the direction of the induced current. And this is how we can get the answer of A. If you want to try out for other option, these are the induced magnetic poles and the induced current for option B. For C, the south pole is moving towards the magnet, so we don't want that to happen. Therefore, that part of the solenoid, the south pole is moving towards the solenoid, and we don't want that to happen. So that part of the coil will take on a induced south pole, and this is the corresponding direction of induced current. And lastly, for part D, when the north pole of the magnet is moving away, we don't want that to happen, and this part of the solenoid will take an induced south pole to try to attract back the north pole that is moving away. And this is the direction of the induced current.